All right. Welcome, everyone. Today, we are diving into a cosmic detective story, one that totally rewrote our childhood textbooks. We're on the case of the missing ninth planet. Let's find out what really happened to Pluto.
I mean, we all learned it, right? 9 planets. You had the 4 rocky ones, the 4 gas giants, and way out there, Pluto. But then, bam, 2006 happens, and everything gets turned upside down. So what on earth changed? What discovery could possibly lead to the demotion of our favorite icy world?
So, to get to the bottom of this, we have to go to the folks who make the rules. That's the International Astronomical Union, or the IAU. Back in 2006, they got together and decided to create, for the very first time, an official scientific definition of what it actually means to be a planet. Think of it like the ultimate checklist for planethood.
And here it is, the 3-point planet test. It's actually pretty simple. Number 1, it has to orbit the sun. Makes sense. Number 2, it needs to have enough gravity to pull itself into a round or nearly round shape. And number 3, this is the big one, it has to have cleared its orbital neighborhood. To be a planet, you gotta check all 3 of those boxes. No exceptions.
Okay, so with these new rules in hand, let's put our main suspect, Pluto, on trial. How does it stack up? Let's run it through the test and see where the evidence points.
All right, Pluto's scorecard. How'd it do? Well, the first 2 tests, it passes with flying colors. I mean, it orbits the sun? Yep. Is it round? For sure. So far, so good. But then, we hit that third, all-important rule.
And this, right here, is the smoking gun, the neighborhood rule. This is the one single test that changed everything for Pluto. So, what does clearing the neighborhood even mean?
Okay, so think of it like this. Clearing the neighborhood means a planet has to be the gravitational bully of its own orbit. It's got to be so massive, so dominant that over billions of years, it's either sucked up, flung away, or captured as a moon, pretty much anything else of significant size in its path. It's the only real heavyweight in its lane.
And this comparison shows it perfectly. Look at Earth's path on the left. It's clean, it's clear. Earth is the undisputed champion of its domain. Now look at Pluto on the right. It's messy. It's swimming through the Kuiper Belt, which is this huge, crowded ring of icy objects. Pluto isn't the king of its path. It's just one of the biggest kids on a very, very crowded playground. And we can actually put some numbers to this to really see the difference. If you took every single other object in Earth's orbit and put it on a scale, our planet would still be over 1,000,000 times more massive. That is what you call total gravitational dominance.
Now, let's look at Pluto. It's a totally different story. In fact, it's the complete opposite. Pluto's mass is only about 7% of the total mass of everything else in its orbital zone. It's not just failing to clear its neighborhood, it's getting outweighed by its neighbors, big time.
So the case is pretty much closed. The verdict is in. Pluto fails the third test. It has not cleared its neighborhood, and because of that one rule, it just can't be classified as a planet anymore. But hold on, it's really important to see this not as a demotion, but as a reclassification. Science isn't about hurting feelings, it's about getting things right. Pluto didn't get smaller or less interesting. Our understanding of the solar system just got bigger, and we needed a new, more accurate category for worlds just like it.
And that new category is the dwarf planet. Just look at the definition, it's perfect. 1, orbits the sun. 2, is round. 3, has not cleared its neighborhood. 4, is not a moon. See? This isn't some runner-up prize. It's a specific scientific label that describes Pluto to a T.
This little chart makes it super clear. A planet and a dwarf planet, they're almost the same thing. They both orbit the sun, check. They're both round, check. The only difference, the one thing separating them, is that final box. Does it clear its orbit? If yes, you're a planet. If no, you're a dwarf planet. That's really all it is. So what this means is that instead of being the weird little oddball at the very end of the line of planets, Pluto now has a much cooler role. It's the king, the prototype, the first and most famous member of a whole new class of worlds out there. And it's not alone. Pluto's got a whole family now. You've got Eris, Haumea, even Ceres, which hangs out in the asteroid belt between Mars and Jupiter. And a fun little history fact, Ceres was actually called a planet for about 50 years back in the 1800s before it got reclassified. So Pluto's not the first to go through this. Yeah, actually, finding Eris back in 2005 is what really brought this whole thing to a head. Eris is actually even more massive than Pluto, so scientists had a problem. Do we now have 10 planets? And what happens when we find another one? 11? 12? Dozens? Or do we come up with a better, more scientific definition? They chose the definition. And that right there is the most important takeaway from all of this. Science isn't just a list of facts you memorize from a textbook. It's a process. It's always moving, always evolving. As we learn more about the universe, our definitions and our understanding have to evolve too. So, taking Pluto off the planet list wasn't the end of a story. It was the beginning of a new one. It opened our eyes to this huge, unexplored region of our solar system. And it leaves us with this really exciting question. What other incredible worlds are just waiting for us to find them out there in the Kuiper Belt?